Hello everyone. Today we are diving into OWASP A022025. We will learn how to spot loud code in a source review and bypass a secured medical portal using nothing but a URL parameter. First, need to know what is security misconfiguration. Security misconfiguration occurs when security settings are not defined, implemented, or maintained properly across applications, servers, and networks, leading to potential exploitation by attackers. In simple terms, security misconfiguration happens when developers focus so much on features that they forget to turn off the tools they used to build them. We're talking about default passwords, open cloud storage, and error messages that talk way too much. Time to look in the source code. When you're reviewing code for A2, you are not looking at logic. You're looking at settings. Here's your checklist for the hunt. First, the loud error. Search for try catch blocks that print the full exception. Red flag is catch exception print. Stack trace. In a source code review, if you see catch exception print a stack trace, you found a security misconfiguration. So I give you the breakdown of red flag first, the catch. The app hits an error but doesn't want to crash. Second, the stack trace. This is a line-by-line map of the server's internal organs. Third, the print. It takes that map and shows it to the user, in simple terms, in a 22025. We call this verbose error handling. It's basically your server talking too much to the wrong people. How fix it? Never leak the guts of your server to the browser. Log the error to a private file for yourself, but give the user a boring, generic message like, an error occurred, please try again later. Second is the configuration hunter. Look for env settings.json, web.config or Docker file. First, the env settings.json. These are the brain of the app. They often contain the most sensitive secrets, database passwords, API keys for Stripe or AWS, and encryption salts. Second, the web.config. This is the traffic controller for Windows-based servers. If misconfigured, it can accidentally turn on detailed errors or allow unauthorized access to subfolders, and then Docker file. This is the blueprint for the entire server. A bad Docker file might run the app as root the most powerful user or include secret files inside the public image by mistake. If you find like hard-coded credentials, admin password, admin 123 in source code, so this is the red flag. Keywords is debug true. Dev mode 1, allow directory listing true. First is debug mode true. This is the most dangerous one. It tells the server, if anything goes wrong, show the user every single detail about our code and database. Then dev mode 1, similar to debug. This often bypasses security checks like login requirements, so developers can work faster. If it's on in production, an attacker can bypass those same checks. Third is allow directory listing. This is like leaving your file explorer open to the public. Instead of seeing a website, a user can browse your folders and download any file they see like your backups or source code. Pro tip: when you're doing a source code review, these keywords are your best friend. Asimple Control F for debug or password across the config files can reveal more about a company's security than a month of active hacking. Let's look at our Health Sync lab. I've simulated 4 classic misconfigurations. First up is default credentials. Many systems ship with admin. In this management console, the developer forgot to force a password change. One guess, and we're in. Next, directory listing. Look at the backup folder. Because the server isn't configured to hide file lists, we can see a env file and a database backup. Just like that, your entire infrastructure is public knowledge. Now check out the verbose errors. When I search for an invalid ID, the app crashes. But look at the console, it's spitting out the JDBC Java database connectivity connection string and the DB service user password. That is a gold mine for an attacker. Finally, the debug parameter. Sometimes developers leave backdoors for troubleshooting. By simply adding debug true to the URL, we unlock a hidden panel that gives us raw SQL shell access. No exploit needed, just a lucky guess in the address bar. I've left the source code for this lab in the description or comment section, so go exploit at home. Remediation. How do we close these doors? It's all about hardening. First is automated hardening. Use CI/CD scripts to automatically set debug false and rotate passwords during every deployment. What is automated hardening? Is using scripts and tools to lock down your system's security settings automatically every time you deploy code. Instead of a human manually checking, is debug mode off? Or are the default passwords changed? A machine does it. Rotate passwords means changing the locks on your house every few months. Even if someone managed to steal or copy your key, it would eventually stop working. Second is generic error handling. Catch every error, but only show the user a reference ID. Keep the technical details in a private secure log file. And third is disable unnecessary features. If you don't need directory listing or a debug panel in production, delete the code. Don't just hide it. Fourth is principle of least privilege. Ensure your web server has the bare minimum permissions to run. Conclusion: misconfiguration is a silent killer because the app works perfectly fine while being totally exposed. Audit your configs, lock your directories, and check your URL parameters. Thanks for watching. Stay secure. I see you in the next video.
ठीक है, एक तो लाइक और शेयर ठोक दीजिए महाकाल का, दबा के लाइक और शेयर ठोक दीजिए, 5,000 लौटे दिख जाना चाहिए।